Hey guys, so here we have for this problem what we call a Hailstone sequence, and it's generated by a positive integer h sub n, and there are three conditions: that if h sub n is 1, then the sequence ends. If it's odd, we multiply it by 3 and add 1 to it to get the next value, or if it's even, we divide it by 2 to get the next value. So for 5, since it's odd, we multiply by 3 to get 15, add 1 to it to get 16. Since 16 is even, we divide it by 2 to get 8, then we get 4, and we get 2, till we get to 1. So for 5, the length of the sequence is 6. So here it asks us to find a number less than 100,000, which has the largest Hailstone sequence, and to find the length of its sequence. So this is how I like to think about problems that involve functions and lots of complicated stuff. So I like to think, first of all, what I need for my input. So I need some boundaries. I need to start somewhere and end somewhere. Here we need to start at the smallest positive integer, which is 1. So I need to start at 1, and I need to end at 100,000 for this problem. In terms of output, we need, in that range, we need the largest Hailstone sequence, so that's a number, and then we need the length of its sequence. The other thing I like to think about are the tools I have available to me. I got if, else if, got else statements, I got these things I can use to compare stuff with, I got these binary operators so I can reduce the amount of ifs and else ifs and such that I have. And I have loops, like I have while loops, for loops, of course a variable, and I have arrays and the properties of arrays we should note. We can access a term, so we can access the third term, which is 2. We can figure out the max, so where does that max occur, and it occurs, or what is the max? So in this case it's 3, and where does it occur? It occurs at the 4th value, so we can find that. We can find the length of it, so in this case it's 4. We can find its size, so that's just its dimensions. And then the other thing I like to think about before I start coding is, how am I going to do this? So what's my plan of attack here? Well, first of all, I need 2 parameters. I need to give 2 outputs. So I need a function that has 2 outputs, a length and then the number. Some sort of name for it, and it needs to start somewhere and end somewhere, right? In this case, we're starting at so in our case, A would be 1, and B would be 100,000. So that function is, the way I thought of it is that function should just go through all these values, and for each value figure out the Hailstone sequence's length, and then it should figure out which one is the longest, and then give me that value that has the longest one and its length, and then it should just end. So it's very clear though that we're missing some tools, right? We need to find the length of a Hailstone sequence for a particular number, and that's the nice thing about functions, is that we can just create another function to satisfy our need for a particular tool. So another thing that we're going to require is to figure out the consecutive values of the Hailstone sequence for a particular number. In order to figure out its length, we need to do that, correct? And we may learn that we may need more functions. to do these things. So this seems like a good start though, a good idea. So let's just start coding and see where that gets us. So we're going to have a function, and we established that it's going to have two outputs. We'll call that for short len and the num. And we're just going to name it max hailstone count. It should start somewhere and end somewhere. So let's start at A, end it at B. Those are just things we can enter. And we're going to need an array of them. And to start off, I'm going to fill that array with zeros. So I'm going to call that count. Could be anything really, but we'll call it count. We're going to use this built-in that'll just input zeros from the first value all the way to the last. So 100,000. And in order to go through each value and do something to that, we're going to need some sort of a loop. And since we know where it starts and where it should end, best thing to do is do a for loop. We're going to call it I from our first value to our last, from A to B. We're going to take the count at that ith value and we're going to count how many numbers are in its hailstone sequence. So to do that, we established that we need to call on some sort of other function. Let's just name that function hailstone count. And that function should have the number that we're looking at. So that number should be 1. Or I, sorry. The first number is, of course, because it's going to start out at 1 when we enter it. So the first number is going to be 1. So that's where it starts. And let's not output that, so put the semicolon there. And that's all we need to do there, really. And now we established that we're going to figure out which one is the longest number. So this, instead of zeros, it's now going to have the length of each hailstone sequence. So like we said, for the fifth one in here, it's the fifth number in here is going to be 6, right? We established that in the example that 5 has 6 numbers in its sequence. So each one is going to have a different value. So we also said that in our tools, max figures out which one has the largest value in this right here. And we said that if we have two values, such as let's have length and num. In our example that I had m and n. The length would be m in that situation, so it would give me the value that is the longest. So the length of the sequence, right? And then the second value would be wherever that longest value, that largest value occurs. So that's going to be the number that has the largest hailstone sequence. So have max of count. And that's just it. It's really that simple. And it's greatly simplified because we called on this function. So now we need to write this function. So we have this function. It's going to have some sort of output. We called it Hailstone count, and we said it would have some sort of variable come in. And in that case, it would be the ith variable. Let's just call it n. So something comes in, and for that number, we're going to need to figure out the number of Hailstone, or the number of values in its Hailstone sequence. So really, we're going to output one variable. Let's call that something like z. So that number is going to at least have one, right? 1 would be our smallest one. It should have the smallest length. So z is going to at least start off at 1. And we're going to need to keep doing something to count the number in its sequence, right? So we're going to need a while loop here. And we don't know, and the reason we need a while loop is we don't know how long the sequence is. So we'll figure out the condition for the while here in a minute. But all we know is if it enters this while loop, it should iterate this and add 1 to it, right? So add 1 to it. And what we need here, so our n comes in the problem. Let's take a look at the problem. Let's take a look at it right here. So our n is essentially, it's the Hailstone number we started off with 5, right? It's the h sub n. So it should take an h sub n and do this stuff to it, right? This is complicated. It's too complicated for me right now. So I'm just going to call in another function, right? Exactly. To figure out the new n. So my new n, I'm gonna call it n. You'll see why in a second here. Let's call this next Hailstone, this function. So it takes in our h sub n to give us our next value, which is, let's make it n to be very simple. So, and it should end there. So basically, what's going to happen is n comes in, it enters this while loop, say n was 5. So n comes in, it goes into this function. This function will calculate now the next Hailstone value. So as we established, it should be 16. So this becomes 16. And it should keep going until it gets to 1. So that's the key thing. That's where this loop should end, right? When n, or so long as n is not equal to 1, this should try and keep calculating the next and the next Hailstone number. And for each Hailstone number, it's going to add 1, and in the end, it's going to give out the length of its Hailstone sequence. If you don't believe me, you can just do every single iteration of this and take a look, and it's going to work. So now we need to figure out how to figure out the next Hailstone number for a particular n, as here it was called h sub n. So let's write a function for that.